Hey everybody, Dave Lindberg with another episode of the THD Podcast. Today, we've got a very exciting technology coming from Tel Aviv, Israel called Addionics, who have done some innovation related to battery cell technology. So we wanted to bring it to you so everybody could hear about how they plan to increase battery life and decrease charge time on battery cells. So as always, we have our guest host from Japan, Simon Weston, calling in. How are you today, Simon?
Doing very well, Dave, and looking forward to hearing about the technology, Gilad.
All right. So Gilad Fisher, the Director of Biz Dev and Marketing, calling in from Israel. Hey, very nice to see you again, Gilad. How are you?
I'm really good. Hi, everyone, and thanks for having me here.
That's great. So, yeah, I met Moshe, the CEO, about a year ago at a tech conference in China, and it's kind of stuck with me of all the different technologies I saw that week. Yours seemed very exciting. Simon and I both have kind of a big interest in consumer products, but can you maybe tell us a bit about where Addionics comes from and some of the markets they can serve with their technology?
Sure. Can I just start the presentation? Will it be the most convenient?
Yeah, let's do that.
Perfect. So let me just share my screen, please.
All right.
So hi, everyone. Thanks for being here. My name is Gilad, and I'm going to be talking with you today about batteries and battery technology. So, of course, the world is on the verge of electrification. We see it everywhere. We have more and more battery-powered products. Everyone is trying to reduce carbon emission and create a better future for all of us. And that one really depends on the battery technology that will be developed in the next few years. So the challenge today is that batteries are not advanced enough if you compare it to other industries. And that caused some limitation in performances, such as Dave mentioned, charging time, capacity, insufficient lifetime. Also, the price is a factor. So if you compare it to other industries, such as chips or smartphones or cars or even consumer electronics or drones, so if you look at batteries from the early 90s when lithium-ion was invented, batteries still look the same, right? Same structure. From the inside, it's a bit different, but the structure is almost the same. And if you talk about smartphones and you compare it to the phones that we have in the early 90s, it's a totally different game. But batteries only improved around 3 to 4% each year. And that is a problem. But we can't really blame the science about it because most of the companies try to improve the chemistry inside the battery. And we think that the key for the next step change is the structure that haven't been changed in the last 30 years. So while most companies try to improve batteries, focus on the chemistry, we focus on the physics. So we create the next generation batteries by smart 3D metal structure, which are smart 3D electrodes. Let me please present a video that will explain and elaborate more about the technology.
Okay. Okay.
Yeah, so I hope that helps to explain about the technology a bit. It's important to say that our core IP is not about the invention of the three-dimensional electrodes. Our core IP is about the manufacturing process, because it's been known for years, and there's many papers about how three-dimensional electrodes can improve battery performance. But no one yet has developed a cost-effective, scalable, and of course patented manufacturing process to produce those metals. In fact, we developed the world's first lithium-ion battery pouch cell with smart 3D electrodes. And right now we're focusing on optimization and integration into consumer electronics products. And of course, our next step is the integration and the packing. As you can see here, this is a real X-ray that we took on our first prototype, which was a coin cell. And this is how it looks from the inside. Basically, we replaced the traditional two-dimensional layered structure of electrodes with a porous one. This allows us to get higher surface area, and that's how we can basically accommodate more energy. As was explained in the video, this porous structure allows us to load more of the active material, which is really unique, and also to reduce the internal resistance inside the battery, as I will show you in a few slides. At the moment, we're developing the 5th generation of high energy cells, and we're working on other prototypes such as lithium polymer that we're going to be talking soon. We are not using only hardware to develop this solution. We're using also software. We're using AI structure optimization algorithms to determine the best structure according to the application. So this is something really, really unique. And this is something, at least as we know, we are the only one who does that. So we're combining the two to do all the production in-house, all the manufacturing are done in our laboratory, and the planning of the structure is also done by our software. And we manufacture the batteries itself with partners that we have in some factories around the world, in Europe, Korea, etc. So this is a demonstration of the internal resistance we got in the prototype that I showed you. As you can see, we can reduce the internal resistance by 50%, which allows to improve also the heat dissipation, the mechanical stability, and more. We also get to very, very, very high cycle life. We can increase cycle life. This is also from the first prototype. We managed to get to 2,000 cycles with only, of course, 20% degradation in capacity. This cell, by the way, is still running some tests. So in terms of the performance, we can reduce charging time by 50% thanks to the lower internal resistance. We can increase the capacity even by double if you're talking about accessible capacity. If you're talking about volumetric and gravimetric, it depends on the case, but we can increase it between 30% to 70%. Again, depends on the application. Our solution is also considered safer due to up to 14 times more mechanical stability, higher mechanical stability, and also thanks to a better heat dissipation in the cell level. We can reduce the temperature inside the cell to between 4 to 7 degrees. And this is very, very important for some of the industries. As I showed you, we can increase cycle life by 100%, and we can also reduce the cost of ownership by allowing this higher energy density and longer lifetime. Our solution is also a cost-effective one due to the fact that it's a drop-in solution. To use our technology, we don't need to build new factories. We can produce our three-dimensional metals electrodes and just replace the ones we produce with existing one in the current assembly line. That means that it can save a lot of money, and also it can be more sustainable because we don't have to build new factories. Our solution is also, you probably understood it by now, but is chemistry agnostic, because most of the companies try to improve the chemistry, as I said. We've improved only the physics. So we can take any kind of existing chemistry that will already been optimized, or emerging chemistry that will come up in the next few years and will win this race. So no matter which chemistry will win this battery race, we don't have to bet on a certain earth. We bet on the whole race. And we're already in development of some chemistries alongside our physics solution. Our solution is also considered sustainable due to the fact that we can adopt any chemistry and any kind of new regulation, such as free cobalt batteries. And because our battery product, the product that will use our battery will last for a longer time, so we support the creation of less waste. Right now, we're working, as I told you, on a few prototypes. One of them is lithium polymer for consumer electronics, and we're already in some kind of collaboration with a few partners to develop the best battery for their product. The core team of the company are all battery scientists, battery experts. They all were researchers in Imperial College London. Actually, they were studied long time ago. They studied the phenomena that cause batteries to explode, which are the metal dendrites. And that's how they originally think about changing the structure of the electrodes, only by looking of this metal dendrites and the way that they grow. Our advisory board, of course, experts in the industry. For example, former board member at Tesla and 25 years VP R&D in Daimler. And also Dr. Parvakar Fatil used to be the CEO of LG Chem, which was the biggest battery factory in the United States, at least until Tesla started building their own. And from Shell, of course, Novelis, which is an aluminum company, so leading experts in all of the industries. We got a lot of recognition from the industry, both the business one and also research team. They stated our technology is being one of the most promising. The EU even called it a game changer in the energy storage market. And we also got a grant of 2.3 million euro from the EU, which was very fantastic. So if some of you saw our Tesla battery day, Elon Musk talked about changing one parameter of the structure of the battery, and they found out that it can improve significantly battery performances. So think what can happen if we change the whole structure of the battery, the whole architecture. And this is exactly what we're trying to do. In terms of vision, so our vision is to integrate our solution into any battery in the world and to support a more sustainable and green future for everyone. And this is possible. Someone will do that. There is no reason that batteries won't use three-dimensional electrodes. And we intend to be the one who does it the best and the one who will do it first. Thank you.
All right. So let's...
So do you mind if I ask you a few sort of questions, bits and pieces? I just picked up in the video, just saw one slide. It mentioned some battery had low energy and high power. Another one had high energy and low power. What's the differentiation between power and energy in a battery?
Okay, so energy is basically the capacity.
Yes.
And power is talking about mostly about discharge rate.
I see. Okay.
Yeah. So when you accelerate with the car, for example, you use high discharge rate. And when you charge your battery fast, you use high charging rate.
And so
that's the difference.
Does it mean that the conventional structures have a trade-off between discharge rate and capacity?
For sure.
Yeah.
For sure. That's why today companies they need to choose thick electrodes or thin electrodes. And our structure allows to get optimal ratio between the both and actually delete this trade-off. So that's very meaningful.
So as I understand it, the concept of dendrites into a cell as a structure to increase surface area has been around a long time. And just because it was coming at us pretty quickly, I just wanted to recap that your core technology is being able to stabilize the manufacturing stabilize the structure, I guess, in reasonable, scalable manufacturing. That's kind of the core behind Addionics.
Yeah. Let me clear the idea. So
okay.
It's a nice story as well. So a few years ago, the founders were investigating those metal dendrites. They were the first team who was looking at this phenomena with real-time microscope. And they found out that there are two interesting things: the way that they grow and their structure. So they thought, okay, maybe we can use their structure for our benefit. And maybe we can also use the way that they grow to manufacture metals. So that's where they were inspired, and that's how the company and the initial idea was invented. Actually, they presented this idea to the EU and got a 60,000 euro grant, but then they couldn't get the money because they didn't have a bank account. So they went to the bank and the bank said, okay, guys, but you don't have a company. How can we open a bank account? So then they opened the company, and that's how the company was established. So that's a really cool story. But the manufacturing process was influenced by the way those metal dendrites grow. And by the way, our structure also prevents them to happen. So this is another advantage.
Yeah, that's the key thing, because we know that they can start growing in some lesser forms of electrodes that are used in batteries around the world, and then they grow and they create a short, which becomes a very dangerous thing, which also exemplifies why your process is more safe than other methods.
Exactly. And also safety is maybe the most important parameter of every new battery.
Yeah, I think anybody that's been dealing in products these days trying to ship batteries around the world, I mean, you guys must have some special techniques in your logistics office to ship samples, because it's, I know over here in Asia, it's very complicated to send battery samples.
It's very complicated. Right now, we can send only the metal to work with our partners. But we're working on some authorization to send full battery, of course. You need to do a lot of tests and a lot of certificates.
Okay.
So I just jump in too. One slide you mentioned 200% more capacity for the same volume. So from a consumer electronics and audio product stuff, all you really care about is volume and capacity. Is there other factors that are equally as important in other industries?
Well, it depends on the industry. For example, the medical devices, they don't mostly care about energy density. They care about longevity and safety. So it really depends on the application, on the industry. Of course, if we take into consideration the automotive industry, this is the most, I would say, it's the only industry where some potential client wants to buy the product because of the battery, because of the range limitation, because they can choose to buy a combustion engine car. So there, the industry will have the most urgency to find new battery technologies because of the range limitation, which is the energy density. But not all the applications are mostly worried about energy density. Some of them about charging time, safety is always the best parameter. And of course, energy density as well. A lot of industries are starting to use LFP more and more, which is considered really safe. And for example, residential energy storage is an industry that's gonna explode in the next 3 to 4 years. Everyone was talking about electric vehicles to reduce carbon emission, but the next industry they will attack is residential energy storage and consumption, and also industrial. And you would see everywhere houses with solar panels and their own energy storage systems.
So the 200%, sorry, just to finish off, the 200% figure is like an indicative number. Is that a function of battery size? So if you have very small batteries, do you have less advantage compared to a traditional one, or more advantage? So of course, I'm asking from the point of view of very small batteries that might go into true wireless earphones or a headphone type of a thing.
Well, the size is more related to the fact that we can load more of the active material even when the battery is small, because the active material impacts the energy density the most. So this is the most important factor. Actually, we have a very positive impact about energy density also in smaller batteries. Most of the consumer electronics products use lithium polymer, and we have pretty good results while using this one. A lot of products today are the earphones and very small energy storage solutions. So, of course, we're looking into that.
Is that energy density factor likely to increase over time, or is that about the limit?
No, for sure it will increase, but the increase is not it doesn't being doubled every 4 years.
Yeah. So your technology makes a step change where you go up by a double, but thereafter it would be a lesser increment.
Exactly. The double increase in energy density is meant mostly to the EV industry because our accessible capacity is really, really high. In terms of consumer electronics, we can promise between, as I said on the presentation, 20-30% to 60-70, depends on a few factors, mainly the battery chemistry, the size as well.
Excellent.
Now, you kind of alluded a bit to the business model in terms of you're selling the electrode parts to the market. Is that to cooperate? Like it looked with your board, especially you've got some key chemistry background guys for the battery chemistry. So is the strategy try to partner with those chemistry people and like let LG or Samsung make battery packs or companies like that?
Yeah, so the business model is divided into two parts. For the next year, I would say, maybe 18 months, we're going to be doing a lot of partnerships with partners from a few industries, mostly from consumer electronics, to prove the integration and the performance of the technology. Same time, we're already working with, I would say, material companies that will be the other side will produce the special metal, the two-dimensional metal. They will produce the batteries, and that's how we're going to create a co-development product and basically a joint venture.
Okay. So kind of license your technology or partner with these guys, give you some protection. I think we've talked about this in the past. It's always a challenging game. How do you deploy this exciting new technology into, the world of consumer products and such? So that's quite.
It is. The business model is one of the most challenging parts because there are so many options. There's licensing, there's joint venture. We can build machines and sell the machines. There are a few options, but we think the most beneficial one is to create a joint venture, and this is the path we're walking through at the moment.
Yeah, well, in my personal opinion, being a part of the project rather than just licensing it, you're in a bit more control of your destiny rather than hoping that a partner makes you a priority. You can make yourself a priority. So that's just my 2 cents, but all right.
I really agree. And also most of the time in terms of income and revenues, it's more beneficial. More responsibility, but more beneficial.
Okay.
Do you have something in the market now? No, our product is not commercial yet. I guess we're gonna be having product in 2.5 years. Depends on the partners, depends on the quantities.
2 to 2.5 years, is that the kind of cycle time for building up a battery and certification and things like that, or is it still in the R&D phase?
No, it's included all the certification we need, but again, it depends on a few factors. For example, if we change our mind and we go with the EV industry, so it's going to take 5 years because the integration is much longer. Yeah. But just to explain, dealing with hardware such as batteries is a long process. Very successful battery companies, battery startups that exist for 7 to 10 years and consider the most promising one. Some of them don't have even one commercialized battery out there. So it's a very, very long process. You really deal with the in-deep physics and chemistry, and to optimize and to stabilize, it's a long process.
And how long has the development been going on so far? Has it been 5 years, something like that?
3 years, actually. 3 years. We intend to be a bit faster because Right now, we're using chemistries that's already being optimized and stabilized, and we're only implementing our physics, our architecture solution. So it's going to be a bit faster time to market comparing to the companies I mentioned.
Yeah, I think the safety thing still comes back into this part of the conversation. Is it's got to be pretty proven for consumer products, and I know with other projects, putting stuff into cars usually takes 7 years to get it through all the certifications. So I don't think you guys are too far off schedule, but very, very exciting stuff. A company definitely that people should watch as you move forward. So you're a privately held company, right?
Yep.
Okay.
We had just a few months ago, we had our last investment. It was a seed investment. In total, we raised around $7 million. A part of it, as I mentioned, while presenting the deck, was a 2.3 million euro grant from the EU, non-dilutive, which is very good for us. And they're probably going to invest in the next round as well. And we're going to start raising money in a guess between 6 to 8 months from now. We're going to be planning our A round.
Very good. Very good. Well, I think, do you have any more questions, Simon?
No, I think that covers it. It's very interesting.
Gilad, anything else you'd like to add?
No, if someone wants to approach me, I'm sure we can find the details. I'll be happily answering any technical question, any business opportunity. Yeah, I think that's it.
Yeah, so we'll put your contact information in the description of the video below. And so, yeah, thanks, Simon, for joining, and Gilad Fisher calling in all the way from Israel. Really appreciate it. So everybody have a good day, and click like and subscribe if you like what we're doing. Thanks, everybody.